welcome back. In this lesson, we're going to look at the definition of the derivative. So if you recall in the last section, we looked at a formula used to calculate the instantaneous rate of change of a function f at a point where x equals a. And that equation was the limit as h approaches 0 of f of a plus h, and h is some constant, minus f of a over h. And what we're going to look at here is something called a tangent line. So if you'll remember from geometry what a tangent line is, the word tangent, a tangent line to a circle or to a curve is defined as a line that touches the circle at only one point. And here's some visuals for you. Here's a semicircle, and you have this segment that's intersecting the circle in exactly one point, P. So we call that a tangent line. Tangent lines touch the circle or the curve once, and they also indicate the direction of that curve. So here we can see this tangent line intersecting the semicircle at that point, right? And we can see that it has a negative slope, because we also said that, this formula here represents a form of slope, right? When we're calculating the instantaneous rate of change. And limits are directly used to calculate the slope of a tangent line at a given point on a curve. If you look at figure 2, you can also see that there are some lines that are tangents, like P1 is a tangent line, and P3 is a tangent line because it passes through the curve in exactly one spot. P2 and P5, for instance, are not tangents because they are passing through the curve. Okay, so they're not touching the curve in exactly one place. So we also have what are called secant lines. And by definition, right, a secant is a segment that intersects 2 points on a circle, or a line in this case. On the outside of a circle. Or a curve. So here you can see you've got this curve, and then you have this secant passing through in figure 3, and here you have a curve, and you have these various secant lines, 4 of them, passing through 1 point on that curve, in which case a tangent line is also passing through that point. So one of the things we're going to do is we're going to find the slope of a secant line. And you can see how it is related to the tangent and then to limits. The slope of a secant line, if you'll recall, slope is change in y over change in x. So if I was to look at, let's say, this secant here, and I want to find the slope of that secant, and you could find the slope of all 4 of these secants here, you would take the y2 minus the y1, so you've got f of a plus h minus f of a over your x2 minus your x1. So a plus h minus a. And as you can see, you're left with this, right? The a's cancel, which looks like the limit as h approaches 0 of f of a plus h minus f of a over h. So the slope of the secant line is the instantaneous rate of change. The slope of a tangent line, also known as the slope of a curve, says that the tangent line of the graph of y equals f of x at the point a f of a is the line through this point having slope the limit as h approaches 0 of f of a plus h minus f of a over h, provided the limit exists. If the limit does not exist, then there is no tangent at that point. Okay, does not exist, DNE, then there is no tangent line at that point. Okay, so let's take a look here. We've got this function, f of x equals x squared plus 2. We're going to find the slope and the equation of the secant line through the points where x equals -1 and 2. So first let's graph this, x squared plus 2. We know that that's just going to be x squared shifted up 2, right? So if you graph x squared, you've got a point at -2, 4. That's going to shift up 2. And you have a point at -1, 1. That's going to shift up 2. 0, 0 shifts up 2. And then we know it's symmetric, so it's going to look something like that. Okay, so there's x squared plus 2, and you can verify on your graphing calculators. So we want to find the slope, an equation of the secant line that passes through the points where x equals -1. So where x equals -1, right, we've got this point, and where x equals +2, we have that point. Okay, so let's take a look at that. So first I need to find when x is -1, what would y equal? So I'm going to simply just plug in -1 into x, and you would have -1 squared, which is 1, plus 2 is 3. And if I was to find the y value when x is 2, 2 squared is 4, plus 2 is 6. So you've got these 2 points, -1, 3, and then 2, 6. So to find the slope of the secant line, that's just going to be f of 2 minus f of -1 over 2 minus -1. And f of 2 is 6, and f of -1 is 3, so it's just 6 minus 3 over 3, which is equal to 1. Okay, so that's the slope of the secant line. How do I find the equation of the secant line? Well, remember, to find an equation of a line, you just need two things, a point and a slope, which is what you have. And we're just going to plug it into our trusty point slope formula. So here I'm going to use the point f of -1, 3, right? So here's my x, here's my y, and I'm just going to substitute in. I would have y minus 3 equals your slope times x minus -1, which would just turn into x plus 1. And then I'm going to just add 3 to both sides, and you would end up with y equals x plus 4. So now if I graph y equals x plus 4, okay, how do I graph that? I'm going to go up 4, and then go up 1 over 1, up 1 over 1. And you're going to see you're going to end up passing through those 2 points. So up 1, so up 4, and then up 1 over 1, up 1 over 1, up 1 over 1. You could go down 1, left 1, down 1, left 1, and here's your line. That's the secant. Okay, so there's your secant line, and the slope of the secant line is 1. Okay, now this is cool too. Find the slope and equation of the tangent line at x equals -1. All right, so to do that, I'm going to find the limit, right? So the limit as h approaches 0 of f of a plus h minus f of a over h. So that's going to be the limit as h approaches 0 of, okay, so now I've got f of a plus h. So I'm going to have -1, that's my x, right? So it's going to be -1 plus h, and we're squaring that and then adding 2. So again, from the last video, right, we're just substituting -1 for x, and x is just a, and we're substituting it back into our equation. So that's why it's -1 plus h squared plus 2. And then I'm going to subtract, and then it's just -1 squared plus 2 all over h. Okay, and I'm going to simplify. So now I would have the limit as h approaches 0. If I distribute -1 plus h times -1 plus h, you're going to end up with 1 minus 2h plus h squared, right? That's just a foiling or expanding. And then plus 2. And then we've got -1 squared, which is 1. 1 plus 2 is 3. Okay, so now I have the limit as h approaches 0. 1 plus 2 is 3, and 3 minus 3 is 0, so that goes away. And you're left with -2h plus h squared over h. And now we want to factor out an h, and you're left with -2 plus h, and the h's cancel. So we end up with the limit as h approaches 0 of -2 plus h, and if I substitute 0 in for h, you get -2. Okay, so that is the slope of the tangent line. But we actually have to find the equation of the tangent line. So we're going to do the same thing. We're going to plug it into our point slope formula. Okay, and again, we can use the same points we used before. It's just we're going to replace this 1 with a -2. So we're going to have this same exact equation, except it's going to be y minus 3 equals -2 times x plus 1. Okay, and we'll just distribute the -2 and then add the 3. So now we get y equals -2x plus 1. So that's the equation of the tangent line. So if I graph that, y equals -2x plus 1, right? I'm going to go up 1 for my y-intercept, and then my slope is -2, so you can go up 2 and right 1, or down 2 and left 1. You're still going to end up on that line, right? So it's going to look something like this, which is really cool because as you can see right here, that's the point of tangency. So you can see there that this tangent line passes through the curve that we drew, right? And the slope of that tangent line is actually going to be the derivative of this function here. It has something to do with the derivative. So you'll see here shortly. Okay. Oh, and that should go the other way. I did not do that correctly. Let me fix that. I apologize. It should go the other way. So I'm gonna still start here. Let me get rid of this. But I'm going to go left, right? Because my slope was negative. I was thinking it was positive. So you go up 1, and then you're going to go up 2, left 1. So you actually end up going through that point. Up 2, left 1. Down 2, right 1. So it looks something like that. Let me try that again. Okay, you can kind of see here how that line, right, is tangent to the parabola. Okay, I'll give you some time here. If you want to pause the video, you can try the check your understanding, and then you can unpause it when you're ready to move on. All right, in example 2, we're going to use the graphing calculator to find the slope of that graph. F of x equals x to the x at x equals 1. Okay, so let's use our graphing calculator, and let's go to y equals, and we're going to clear that. Now we have x to the x power. So I'm going to click on x, and then the caret, and the x again. And you're going to have to change the window. So let's make our window, let's do 0 to 2. You might have to play around with it to get this to work when you graph these kind of things, but this window seems to work best. And then 0 to 2 as well for both your x max and then your y max. Okay, and then we'll be able to see a nice picture of the graph. So if we just take a look at the graph, that's what it looks like. Okay, it's zoomed in, of course. And we want to find the slope, right? So we need 2 points. So we can always get that from the table. We want to go back to the table set. And this time we want to change the independent to auto, right? We want the calculator to give us some values for x. And then we're going to go to second graph. And then here we have some values to use. So one of the easiest ones to use would be 1, 1. And we can always choose another one. We can even pick 2, 4, right? or we can pick something closer to 1. So we want to kind of do that. So let's go back to table set, and this time let's go to ask for independent, and let's go to the table. Let's clear out. If you have anything in there, just delete it. Okay, and again, we'll use 1, 1, but let's pick a number that's close to 1. Like let's do 1.00, I don't know, 1512. Okay, and let's see what it gives us. So we're going to use these points. All right, we want to pick something very close to 1 since we're trying to find the slope of the graph at that point, x equals 1. Okay, again, in order to see the value for y1 for when x is 1.001512, you want to highlight that so that you can see the whole thing. So you can really see that it's 1.0015 looks like it should be 1, 4, right? Okay. So our 2 points again are 1, 1, and then 1.001515 and I don't remember what the y value was. Oh, well, that's good enough. So that was 1.001512. And then the y is 1.001514. Okay. So we're just going to find the slope, right? And it's going to be approximate. So I've got my y2 minus my y1 all over my x2 minus my x1. And when you do this, you get something close to 1. Okay, and you can see that here. So if I go back, second quit, and I type in, it was 1.001514 minus 1, and then it was 1.001512. Right, and we get something very close to 1. So it's approximate. Okay, now if we were to figure out the tangent line to that graph, right, at that point, you would see that the line would pass through in exactly in one place on that curve and have a slope of 1. At this point, you can pause the video and try the next problem on your own, and then let's talk about derivatives. So the derivative of a function f at x is defined as f prime of x, which is the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so, and this right here is pronounced f prime of x. Provided that the limit exists, of course. Okay. If x is a value in the domain of f, and f prime, the derivative, exists, then we say f is differentiable at x. Okay, the process that produces f prime is called differentiation. So this little table here kind of shows the comparison between the different interpretations of the difference quotient, which we talked about in the last video, and the derivative, right? So the difference quotient just doesn't have the limit next to it. The difference quotient is the slope of the secant line, whereas the derivative is the slope of the tangent line, which is what we talked about just a few minutes ago. The difference quotient represents the average rate of change, whereas the derivative is instantaneous rate of change. This is the same formula we looked at when we looked at instantaneous rate of change. The difference quotient represents average velocity, and the derivative would just be instantaneous velocity. Some examples of using the difference quotient would be for average rate of change and cost, revenue, or profit. For the derivative, it would be marginal cost, revenue, or profit. Because remember, it's the slope, and the slope is the marginal. To find the derivative of a function using the definition, we're just going to follow these 4 steps. So basically, these first 2 steps are just the numerator here in step 3. So when I do this, I'll split it up into the steps so you can see it the first time. But then I'm going to do it overall, just in one giant problem. So the first thing we're going to do is find and simplify f of x plus h. Then we're going to find and simplify f of x plus h minus f of x. So that's the numerator, right? Then we're going to find and simplify the quotient. And then we're going to find the limit as h approaches 0. Okay, and that will give us the derivative. So let's take a look at an easy function, f of x equals x squared. And let's say I want to find the derivative. Okay, so how would I go about doing that? So using the steps, the first thing I want to do is I want to find f of x plus h. So all I'm going to do is substitute x plus h in for x there. So you would just end up with the quantity x plus h squared, right? And we know if we FOIL that out, you get x squared plus 2xh plus h squared. Okay, that's step 1. Step 2 is to find and simplify f of x plus h minus f of x. So we already know from step 1, f of x plus h is just this. But now we're going to subtract f of x, and f of x is x squared. Okay, and as you can see here, the x squareds cancel. So you're just left with 2xh plus h squared. Okay, step 3 is to simplify the difference quotient. Okay, and steps 1 and 2, like I said, are the numerator. So you're just left with this. And then we can factor out an h in the numerator. And the h's cancel. And you're just left with 2x plus h. And then step 4 is find the limit as h approaches 0. So that'll give us the derivative. F prime of x is just going to be the limit as h approaches 0 of 2x plus h. And if we substitute 0 in for h, you end up with just 2x. So the derivative of f of x equals x squared. So therefore, of f of x equals x squared is f prime of x equals 2x. Okay, let's take a look at the graph. Okay, let's go to y equals. Let's clear that function out. And let's look at these two graphs. So we've got x squared, which is our original function, and then we've got 2x and we have to change our window. So I'm going to make that negative 10, positive 10, negative 10, positive 10. And then just go to graph. And you can see the parabola. And then you can see the line passing through. All right. Let's figure out now, calculate and interpret f prime of 3. So we know f prime of x is 2x. So f prime of 3 is real easy. We're just going to substitute 3 in there, and you get 6. Okay, so that's just the slope of the tangent line to the graph of f of x equals x squared at the point where x equals 3. Hi everyone, and welcome back to part 2 of this video. In the last problem, we found the derivative of f of x equals x squared, and the derivative of that function was just 2x. Now we're going to calculate and interpret f prime of 3. So we know that f prime of x was our derivative, that was 2x. So to find f prime of 3, I'm just going to multiply 2 times 3, which would give me 6. And what that represents is it's the slope of the tangent line to the graph of f of x equals x squared at the point where x equals 3. So you can pause the video and try the next problem, and then you can unpause it when you're ready to move on. These are just some equivalent expressions when you see the phrase change in x, right? x2 minus x1 is used for describing the equation of a line through 2 points. We use b minus a. You may have seen that in some of the formulas that we've reviewed. It's just a way to write x2 minus x1 without using subscripts. Change in x is useful for describing the change in x without referring to the individual points. And h is a way to write change in x with just one symbol. Okay, which, if you think about, again, that common theme of slope, right? How do you find slope? Change in y over change in x. So h is just change in x. All right. In example number 4, we have a new function, 2x cubed plus 4x, and we want to find f prime of x, so the derivative, f prime of 2, and f prime of negative 3. And these will be easy once we find that. So I'm going to, take the 4 steps we looked at the other day, and I'm just going to combine them into one giant step. You're welcome to do each one separate. However, I'm not going to do that. I'm just going to combine it. So to find the derivative, right, you want to find the limit as h approaches 0 of f of x plus h minus f of x, and then over h. Okay, so here we have the limit as h approaches 0, and we're just going to take x plus h and we're going to substitute it in where the x is. So we have 2 times x plus h cubed plus 4 times x plus h. Okay, minus f of x, and I'm putting that in brackets because we're subtracting an entire quantity, and then it's all over h. Okay, so the limit as h approaches 0. Now I'm going to expand everything. So I'm going to have to expand x plus h cubed, right? So real quickly, x plus h cubed is just x plus h squared times x plus h. And we know x plus h squared is x squared plus 2xh plus h squared. So then we just need to FOIL this, right? So we would multiply those two terms, and then those two terms, and then those two terms. So that's how I'm going to come up with this next expression here. So you end up with 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed, and then it's a 4 times x plus h, and then it's still minus 2x cubed plus 4x all over h. So now I have the limit as h approaches 0. We're going to clean this up, right? So we're going to distribute the 2 everywhere. And then distribute the 4. And then distribute the negative. Okay, and we got to clean this up even more. So let's see, we've got a 2x cubed and another 2x cubed. Those are going to go away. We've got 2x squared h. So that will, let's see. Oh, that should be 6x squared h. Because it was 2 times 3. So I still don't see any other x squared h's. So that's going to stay there. And then we've got 2xh squared. Okay. We've got a 2h cubed. And then a 4x and a negative 4x. They're going to cancel out. And I've got this 4h here all over h. Okay, and we can factor out an h. And the h's cancel, which is a good thing because we're going to be substituting in 0 into this expression. Right? And then all I'm going to do is plug in 0 everywhere there's an h. And we can see those cancel out. And you just get 6x squared plus 4, which is the derivative of the function we started with, 2x cubed plus 4x. So now I can actually find f prime of 2 and f prime of negative 3, since I have f prime. So f prime of 2 would just be 6 times 2 squared plus 4. And that would give me 28. And then f prime of negative 3 is just going to be 6 times negative 3 squared plus 4. And that would just give me 58. Right, so again, this is going to be the slope of the function where x equals 2. And this would be the slope of the function where x equals -3. Okay, you can pause the video and try the next one. See how you do with that. If you have any questions, you can always reach out to me. Here's another example we have. So we've got f of x equals 4 over x, and we want to find f prime of x. Okay, so I'm going to just do all 4 steps combined. I'm going to plug in x plus h. So I have, and I actually don't even need these brackets because it's just 4 over x. So it's just going to be 4 over x plus h, and then minus f of x, and then all over h. Okay, so I get the limit as h approaches 0. Now, in order to subtract these two rational expressions, we don't have the same denominator. So we have to find a common denominator, and the common denominator would just be x times x plus h. Okay, so my LCD is x times x plus h. So what I'm going to do is I'm just going to take each of these and multiply them by the piece they don't have. So this is missing the x. And then this one is missing the x plus h. And then this is all over h. So now you have the same denominator, x times x plus h. And I can just combine my numerators. So now I have the limit as h approaches 0 of 4x minus, now remember, you're going to distribute the -4, so you end up with -4x minus 4h, and then all over h. X times x minus h, or plus h rather. Okay, and then all over h. And these go away. So you're left with the limit as h approaches 0 of -4h over x times x plus h divided by h, right? And to divide by h means to multiply by 1 over h. So now you can see that these h's are going to cancel. And we're left with the limit as h approaches 0 of -4 over x times x plus h. And then we'll plug in 0 for h, and we're left with -4 over x times x plus 0, which is just -4 over x squared, or you can write it as -4x to the -2nd. Okay. Next, we have a cost problem that you can try on your own. So here's an application. Let's talk about the equation of the tangent line. So the tangent line to the graph of y equals f of x at the point x f of x1, so x1 comma f of x1, is given by, and this will look familiar, it's just the point slope formula, y minus y1, when your y1 here is f of x minus, or f of x1, equals m times x minus x1, right? And what is m? M is the slope. And what's the slope? It's the derivative. So I'm just gonna get rid of this, slide this down, and it's the derivative of x1. Okay, so that's all the slope is. And that's all the derivative is. It's the slope of the tangent line. Okay, again, provided that the derivative exists. Okay, so it says find the equation of the tangent line to the graph of f of x equals 4 over x at x equals 1. So what I have here is y minus y1, right? And what's y1 here? It's just f of 1. Equals f prime of 1, that's your slope, times x minus 1. Now, if you'll recall from the last example, we found f prime, right? So our f prime from this example was negative 4 over x squared. So, in other words, the slope of the tangent line is f prime of 1, which was just negative 4 over x squared. So it's really just negative 4 over 1 squared, which is negative 4. Okay, and since f of 1 since f of 1 is equal to, or f prime of 1 equals negative 4, we're looking for the tangent line to f of x at the point 1, 4. Okay, so since f of 1 is 4, your original function, since you plug in 1 here for x, you get 4 for y. Since f of 1 equals 4, we're looking for the tangent line to f of x at the point 1, 4. So again, I'm just going to use my point slope formula, and I would have y minus y1, which is 4, equals m. M is your derivative, so negative 4 times x minus x1. Okay, and again, I got this, just a random point, by plugging in a value here, x equals 1, here. Okay, and then you'll just go through and use some algebra there, so you get y minus 4 equals negative 4x plus 4, and then you would add 4 to both sides. You would get y equals negative 4x plus 8. And that's the end of this video. Here's just a quick summary for the conditions for the derivative to exist or not exist. The derivative exists when a function f satisfies all of the following conditions at a point. F is continuous, f is smooth, and f does not have a vertical tangent line. The derivative does not exist when any of the following conditions are true for a function at a point. When f is discontinuous, f has a sharp corner, or f has a vertical tangent line, right? Because vertical means the slope is undefined. Have a great day, everyone. If you have any questions, please reach out.